Hi, and welcome to Conversations with Des. I'm your host, Des Blanchfield. Now, today I have the privilege of being joined by Jeni Panhorst. Now, Jeni is the Vice President and General Manager of Network and Edge Platforms Division at Intel Corporation. Jeni, great to see you. Thanks for making time, and welcome to the show.
Thanks so much, Des. It's great to be here.
Now, let me just quickly introduce you to our audience. Jeni leads a team which delivers silicon, software, and platforms for network and edge computing infrastructure to drive transformation across wireline, wireless, cloud, and enterprise networks, which is a very broad remit, and we'll get into that in a little bit. But Jeni, I just wanted to highlight that as a proud parent, and in particular our 18-year-old daughter, I've been a long fan of your amazing work, not just in your professional role, but also your amazing work in mentoring. And in particular, I love seeing that you'd introduced what I call reverse mentoring into that and how it played into that whole balance between intergenerational mentoring. And I just want to say congratulations on amazing work.
Yeah, thanks so much. And it's great to hear that you're interested in that as well. You know, after a couple of decades in industry, I think that there's just this inherent desire to really reach out to others who are, who are either within, my organization, my company, or across the broader industry. Frankly, a little bit selfishly, there's just so much to learn from, the other folks who are coming up, in the generations behind, just the way that they view technology, the opportunities to solve a lot of the world problems that we're facing, which I think are, it's just very inspiring when I look at some of the problems that we're seeking to solve in networking as well as in edge computing. So I'm a parent of teenagers myself. I learn from them every day. So it's a really important thing that I'm very passionate about.
Indeed, and I fully agree with all of that. In that, I think it behooves us in many ways that whatever we've learned in our lives, we can play that forward or pay it forward, as they say. But also, I, as you do, like my teenagers are constantly surprising me by how they can convey really complex ideas in such simple ways. But I guess that's a generational thing. I absolutely love it. So big fan of that. Now, I was wondering if we could talk about some of the exciting things that have just come out from your organization. So firstly, congratulations on the new second generation Xeon scalable processor and the exciting new system on chip, the Intel Atom P5900. Exciting at both ends of the spectrum, at the big end of town as far as the data center and the cloud end of things go, and also the other end with the Atom system on chip with the edge and all the things that are around that, particularly with what the likes of 5G is going to require. I wonder if maybe we could just kick off with an introduction, in particular to the new Intel Atom P5900, and maybe an overview of the actual target markets it was designed for.
Yeah. That entire portfolio of products that we've launched in pursuit of the 5G opportunity is really exciting for us. And yeah, if we look at you wanted to dive into the Intel Atom P5900, what's really exciting about that product line is that it's really the first Intel architecture SoC for wireless base stations. So, for anyone not, who doesn't live and breathe networking every day, of course, we hear about 5G. 2020 is a huge year for 5G, really launching and ramping in earnest. But the wireless base station really represents that first stop in the mobile network from our device to eventually connect us back to all the great services that we now have access to right in the palm of our hands. And so this product, the Atom P5900, is focused on what we call the layer 2 and layer 3 aspects of the wireless base station, the transport, the packet processing, the control plane processing. And so with the addition of this product to the overall portfolio, it really augments our existing silicon portfolio. You mentioned the Xeon scalable processors to provide really solutions across multiple different types of networking environments. And introducing Intel Silicon as that foundation for the wireless base station market. And with 5G ramping, represents an opportunity of nearly 6 million base station deployments forecasted out through roughly 2024, or what some of the analysts are saying. And so now we've really got an opportunity to expand Intel architecture from the core of the network through the access and the edge network, which provides great scalability for the investments of those responsible for developing and deploying network equipment. And so, there's a lot of really great goodness that we built into this next generation system on a chip, focusing really on the unique needs of those base station workloads. We were able to increase overall performance of secure networking, increase performance of packet processing and load balancing. And so we've seen some really great results and really great uptake and design-in activities with a number of customers who are responsible for building those next generation 5G base stations.
Indeed. In fact, a couple of the points that you touched on, I mean, one of the biggest challenges we've had from a design point of view is often multiple proprietary platforms to try and integrate. I think one of the great things this has now made possible, beyond all the things you talked about there, which were key, was that we now have this whole Intel architecture, or IA as we call it, from the data center and the cloud infrastructure all the way to the edge and the devices
Yeah,
themselves, even the endpoints. Now, as you said, even to the likes of essentially a base station on the top of a pole. And that just makes everything so much simpler from a design point of view, software deployment point of view, and particularly now that everything's
exactly.
software-defined infrastructure. So with that in mind, I wonder if we could just dive into a little more detail specifically around where the Atom P5900 system on chip platform fits, in particular with comparison to the rest of your ecosystem, and specifically the latest Xeon D family of system on chips.
Yeah, you mentioned before the remit that we have in the networking business at Intel across, not just wireless and wireline networks in telecom networks, but also cloud and enterprise networking. And so there's a great diversity of what is needed across those different locations, different design points in terms of performance and power and price, and also the types of workloads that need to be supported. And of course, we want to be able to address that level of scalability with, consistent software approach, and really being able to leverage that scalability across those different locations. And so really offering a silicon, compute portfolio that addresses all those different design points is really important, from the scalability, from the level of the Atom P5900 up through our Xeon D, and then even our Xeon Scalable products that you mentioned earlier. So if you look at, what we're seeking to address with the Atom P5900, it's really focused on delivering a performance per watt profile that's really suited for those cell sites that are outdoors. And I mentioned before the fact that we've got, packet processing performance, that we're seeking to address our secure transport performance, that improvements that we drove. And so we've got integrated accelerators, integrated IO capabilities that are in that system on a chip in order to address those needs. By comparison to prior generations of designs from telecom equipment manufacturers that really relied much more heavily on ASICs or application-specific processors to deliver the same functionality, now we've got an ability to do that with a general purpose system on a chip that has some specialized acceleration to address those workloads. By contrast, with the Xeon D products, that's really a focus on delivering, improvements in overall single-threaded performance for server class workloads that can enable, additional form factors focused on density and scalability, and really focused on a broader set of workloads across those different network locations. And so it really is just about addressing different design points, and in some cases, specialized acceleration and IO to target different parts of the network.
Indeed, the telecom industry has certainly been looking for essentially what you've just built now, which is that ability to do the switch fabric component, where they don't have a lot of compute, they just want to move packets quickly. One of the features I loved was the ability to load balance multiple types of channels going through this thing. We've heard a lot about what Intel's doing around the space of particularly Intel's Converged edge reference. I should say that Intel's Converged Edge Reference Architecture, that's a mouthful, or CERA, and in particular the Open Network Edge Services software that you've got. I wonder if firstly you can maybe just introduce both of those, and then tell us what you're doing as far as your investment in virtualization and scalability computing at that core to the edge journey. Maybe if we just start first, Intel's Converged Edge Reference Architecture, maybe if we can just introduce what that is and where it fits into the world.
Yeah, really the most exciting thing, I've been working in networking now for a couple of decades, and it's so exciting what's happening, because now with the move of networks to virtualized deployment models, cloud native deployment models, this increase in need for computing at various different edge locations, we've now got an opportunity to take those virtualized server-based solutions that network workloads are being deployed on, and either on those same platforms or next to or near those same platforms deploy edge computing capacity. And that's really what the Converged Edge Reference Architecture is about. It's about really providing capabilities, integrated capabilities that enable abstraction of underlying network architecture, and being able to make that more accessible to edge developers who really want to be able to program the edge just like they're programming a cloud. And they don't necessarily want to understand or need to understand the underlying network, but you still need to be able to provide that programmability and that visibility into what's happening in order to deliver on that next generation set of edge use cases that demand high quality of service. And so the CERA is really all about pulling together different pieces like OpenNESS, which you mentioned, other capabilities like OpenVINO focused on edge inference for visual workloads, and other capabilities like Open Visual Cloud focused on media workloads. And so it's providing a reference architecture in order to speed development and deployment of those next generation edge solutions.
And the name's fairly obvious, but I wonder if we could maybe get an introduction from your point of view as to how you describe your open network edge services software. Obviously, you've just covered the architectural reference, as it were, reference architecture rather, sorry, but maybe if we just delve into your open network edge services software, and I guess it plays to that same challenge that, as you said, we're looking for sort of those API accesses to services now rather than having to go down to socket level C programming to get a connection, right?
Exactly. That's exactly the goal. And OpenNESS, we've made a lot of progress really in just the first 9 months, just a handful of releases that we've had so far in OpenNESS, but we've got a lot of really good uptake from a number of different developers because they really see this key value proposition of taking advantage of an open source reference toolkit and using that as a way to foster faster development of those edge solutions. And so, it does all of those things that I talked about before, right? Abstracting out that complexity of the network to cloud developers, providing an interface to be able to onboard and manage those next generation edge applications. And so even though it's abstracting the network complexity, it's allowing access to key capabilities like access termination, traffic steering, multi-tenancy for a variety of services, authentication, telemetry, all of those capabilities of the underlying infrastructure that a developer needs to have access to for those next generation services, but wants a bit of an easy button to do that. And so that's what OpenNESS is enabling for them.
It's fantastic, and congratulations on both of those initiatives. I think they play directly into the two biggest concerns I'm seeing from the entire carrier and service providers industry as a whole, and that is reducing the time to market in the first stage of getting something from MVP to actually working and being monetizable, and the reduced time to a return on investment for them, because they've got some very large sunk costs in everything from wire in the ground to things on top of poles, and now they want to iterate faster. So I think you've met both of those requirements very, very nicely. I wonder if you can give us some examples of some of the customer or partner engagements that are now leveraging these solutions in particular.
Yeah, I love what you just said around, really trying to leverage existing investment and use it as a jumping off point for future innovation. And so, I like to kind of liken the, kind of the edge revolution that I believe we're sitting on the cusp of as, kind of akin to what happened with the mobile and the cloud revolution of, a decade plus ago. And really, when you think about, kind of the advent of mobile devices and the capacity that was generated through not just connectivity, but access to cloud computing capacity, at the time, there were some use cases that we could have dreamed about, right? But now what's become so pervasive in our lives, those were all use cases that hadn't yet been invented. Really what it was about creating a platform for innovation. And that's really what we're seeking to do here again, just in a new way. And so if you look at, a couple of the engagements that we have so far where some of our partners are really, seeing value in a capability like OpenNESS, it really is to create network edge locations, enable them as infrastructure as a service, platform as a service locations that can then be leveraged by cloud service providers and developers and enterprises in a variety of different verticals to deploy end-to-end edge services. And so one great example of that is a partnership we have with China Unicom. And they've been able to take various microservices from OpenNESS and integrate them into their multi-edge access compute platform or MEC platform. And they did a partnership also with Tencent in order to enable and deploy their cloud gaming applications. And those were cloud gaming applications that required augmented reality, virtual reality. And of course, if you know about those applications, they typically require very high bandwidth, but also very stringent latency and jitter requirements. And so they're ripe for edge computing types of deployment models. And so they use that as kind of an initial platform to deploy those services and deliver better quality of experience to their consumer end users. But really, it just becomes a jumping off point for the next generation of edge services as well. And so the other thing that we've been doing with China Unicom is actually sponsoring developer workshops and boot camps to be able to recruit additional edge developers and create that kind of upward spiral effect for that next generation of edge services. So we're really excited about that.
I love the sound of that. It's in effect a tailor and purpose-built sort of hackathon approach to finding people who've got great ideas and essentially building a platform and facilitating that. And I think that's very exciting. I think that's where we're going to see the next big innovations. I know that you've got some big partners like Honeywell who are using this technology in their security space. You've got
Yeah.
Siemens Healthineers is using in health space, and right out to the edge of the network, as it were, with scanners and devices. But I think it's those unknowns where people have got great ideas. They may not yet have access to the tools. When you run these sort of hackathon style approaches or workshops, they now get that access. They get the education awareness, and then these ideas just come out of nowhere and blossom. And we've seen a whole range of these things, from food delivery to instant cars to who knows where the next one's going to come.
Remote healthcare, telemedicine, which is very relevant to what we're facing in the world right now, right? So
Indeed.
yeah, tons of very valuable use cases.
I can see a scenario where a little device is shipped to me with haptic feedback of some sort and tells me, does it hurt here? Does it hurt there?
Yeah.
It's like we're living the George Jetson's world, except I'm dying for the flying cars.
Yeah.
Well, there's no secret that Intel's been playing a lead role in this whole space for a long time, not just in networking, but certainly in telecoms, and everything from the handsets through to the infrastructure that's making those handsets able to work.
Yeah.
But I mean, you're also playing a leadership role in the whole collaboration and open source space. And I wonder if we could maybe just delve into how our customers are responding to that, because I know some of these telcos have come from very proprietary and closed shops. Now they're sort of moving into the sort of DevOps, orchestrated, automated world of cloud and software-defined infrastructure, software-defined networking, NFV, very open sourcey, and sometimes that isn't native to them and natural to them. And I was very keen to get your insights and kind of how that seems to be playing out. It seems to be positive on the whole, but I'm sure you've got a great internal view of it.
Yeah. I mean, open source collaboration has been a cornerstone of Intel's strategy to drive open ecosystems, for innovation on general purpose computing for eons, right? And so really, we drew upon that success, that Intel on the whole had in really driving our strategy for networking infrastructure over the course of the past decade plus. And really what it was an awareness of the fact that community collaboration really drives innovation and iteration to deliver the best solutions that can be leveraged across the broad ecosystem. And we are talking about industries that don't exactly move, incredibly swiftly, but this is a way to spur on that innovation and be able to accelerate that overall development. And I think, one of the best success stories, pretty undeniably, is that of DPDK, or the Data Plane Development Kit, which, many of your viewers may be familiar with it, but, for those who aren't, it's a set of libraries and drivers for high performance packet processing on CPUs. And actually, I don't know if you knew this, but DPDK is turning 10 next month in April. So yeah, April 2010 was the first time when Intel released that under an open source license. And so it started out as an Intel focused project, but expanded into a community, and it's grown to support multiple operating systems, CPU architectures, accelerator architectures, network interface controllers, and today is a thriving community in the Linux Foundation. And that's just one of dozens of examples of success stories that we've had that have made an impact in networking. And I think really the latest example is the one that I just talked about with OpenNESS. But you look across networking, you've got projects like Open vSwitch and P4. You look at orchestration projects like OpenStack, Kubernetes, what's happening at the edge with Akrano. I mentioned OpenNESS, what's happening in the RAN with ORAN. I mean, so there's just so many examples of, this really being kind of a preferred approach to drive innovation. But then coupled with that, we also need incredibly strong commercial tasks for those open source innovations. So, what we drive through our ecosystem with our OSV and ISV partners, but also our partnerships across the OEM as well as telecom equipment manufacturer ecosystems and system integrators is really critical to accelerate the development and deployment of those solutions for the operators.
I imagine it's, and congratulations on now having a teenager open source project. That's pretty exciting. Going from single digits to double digits. We know that something's got longevity if it gets to that point. But I wonder if, one last quick question just to wrap up then. When you're talking to these organizations, it seems to me that there must be a level of excitement for them now when they finally realize that this flexibility and dynamic capability to take an idea that either comes from consumer-driven demand or their own innovation internally, that they can now iterate this so much faster, and that is not a 3 to 5 year turnaround. It could be 3 to 5 weeks or months at the most to take an idea, write some code around it, deploy it, whether it's something in Docker and running under a Kubernetes cluster on OpenStack or VMware on your platform from the data centers that they might be running themselves or third party or cloud, all the way out to the edge where the signals are actually being detected. There must be just such a sense of relief and excitement that now this is actually even possible.
Yeah, Yeah, definitely. And I think relief, but at the same time, a lot of burden, I think, on all of
Yes.
our shoulders about how much work there is left to do. But it's
Right.
super exciting because I think we've got all the right tools, that are, kind of underway and in development in order to really spur on, that next generation of innovation. And so I think there are a lot of really great points, in areas that we can engage. I mentioned the OpenNESS community. I'm super excited about it. Definitely, go to openness.org. Great opportunity to engage with us there, take a look at what we're doing, and partner with us to innovate. But another great place just to kind of look at the broad ecosystem that Intel has enabled for networking is Network Builders. Intel Network Builders, you can go to networkbuilders.intel.com, and you can find a number of the tools that we have available to accelerate that development. We've got solutions briefs, we've got blueprints, we've got education through Network Builders University, and then of course access to the hundreds of partners that are within that ecosystem. So really great place to find out what we're doing and understand ways that we can collaborate together to accelerate this next generation of development for networking and edge in the 5G era.
Fantastic. Well, Jenny, thank you so much for that wonderful wrap up. And indeed, we'll include all of the links to the relevant projects and Network Builders portal on the Intel website, because it is an amazing resource. And as you say, it's a great way to get started, because it's sometimes daunting to sit there with a clean screen and no lines of text on it,
Yeah,
to wonder where to get started, and to be able to download some examples and work with other people and collaborators is a great way to do that. But thank you so much for your time. It's been great to chat
absolutely.
to you individually and personally, and also get a little insight into kind of what you're doing in this whole space. But certainly some of the amazing insights you just shared around where you're going. I think there's no question that you've absolutely provided an amazing platform now with the system on chip with the Atom P5900. I think now the opportunities for partners and integrators and developers to get onto this platform and drive some of these innovations that we're all waiting breathlessly for, and an exciting future for us all. And thank you so much for making time to share that with us.
Absolutely. Thanks, Des. Onward and upward with 5G and edge. So thanks so much.
Indeed, I'd like that on a t-shirt. Thanks, Jenny. Appreciate your time. Cheers.
All right. Thanks.